We have another Math Olympiad problem, an interesting one. It says if a plus 2 times ab plus b is equal to 8 and a and b are integers, asking us to find what's the value of a plus b is equal to. Let's see how we can find that. So we have a plus 2 times ab plus b is given to be 8. What I will do is I will use a little technique. I will multiply both sides of this by 2 first. So it's 2 times a plus 2 times ab plus b is equal to, on the right 2, I'll multiply by 2. So it's 2 times 8. Here, after distributing, what we get will be 2 times a plus 2 times 2ab will be 2 times 2 is 4. So it will be 4ab plus here 2 times b will be 2b will be equal to 2 times 8, which is 16 on the right. Then what I will do is, because there is a 2 times a term that is common for both these terms, the first two terms, I'll take that 2 times a common for the first two terms out of those two terms. Then what is left here will be simply 1. And here once I take a 2 times a out, another 2 and a b term will be remaining. So it's plus 2b that's left there. We can always double check distributing. We should be able to get both these back. And it is the case because 2 times a times 1 is 2 times a. 2 times a times 2 times b will be 4ab. We still have this plus 2b term there. On the right, it's 16. Then what I will do is, I will try to create the same 1 plus 2b factor here as well using this term. To do that, what I will do is, I will add 1 to both sides. So we have 2a times 1 plus 2b here. Then I will add a 1 to the left-hand side. We still have that plus 2b term there. And I'll add that same 1 to the right-hand side as well so that we can continue with the equality. Then we can write these together like this. We see that for both these terms now, 1 plus 2b term is common. That 1 plus 2b term that is common for both these terms, I'll take that out in the next step. So once I take that 1 plus 2b term out of this term, another 2a will be remaining. And once I take 1 plus 2b out of that term, only thing that's left there will be simply plus 1. We can double check by distributing it. We will get both these terms back. 1 plus 2b times 2a will be that. And 1 plus 2b times plus 1 will be that. So nothing wrong with taking that common factor out and writing it in the factored form like this. On the right-hand side, it's simply 1 plus 16, which is 17. Now, it is given that a and b are integers. Now, if a and b are integers, if a is an integer, 2 times a will be another integer plus another 1 will be another integer. So 2a plus 1 will be an integer. Same way, because b is given an integer, 1 plus 2b will be an integer. So what this says is we have an integer product that equals 17. Then what can these integers be? When we multiply two integers, if it gives 17, then these will have to be the integer factors of 17. And we can get 17 by multiplying the two integers 1 and 17. And also it is possible to get 17 by multiplying -1 and -17, multiplying these two integers as well. These are the only integer products that give me 17 when I multiply two integers. Therefore, these are the only possible choices for these two integer numbers. So 1 plus 2b can be 1 and 2a plus 1, 17. Or it can be the case that 2a plus 1 is 1 and 1 plus 2b is 17. It doesn't matter which one is which, because what we are asked is to find a plus b value, not a and b separately. Same way, it can be the case that 1 plus 2b is -1 and 2a plus 1 is -17. Or it can be the case 2a plus 1 is -1 and 1 plus 2b is -17. Again, it doesn't matter, because it's a plus b value that matters. So what we can do is we can set them separately and solve. Let's consider in case if these two numbers are 1 and 17, what's the value of a plus b is. So if the product is 1 and 17, then 1 plus 2b should be equal to 1, and 2a plus 1, this should be equal to 17. Like I said, it can be the other way around, like 2a plus 1 can be 1 and 1 plus 2b can be 17. But again, like I said, because what they're asking us is to find the sum a plus b, it doesn't matter what's the value of a and what's the value of b. It's the sum that matters, a plus b. So if this is the case, from here we get b to b. Now 2b will be 0 once we subtract 1 from both sides, and dividing by 2, if 2b is 0, b will be 0 as well. Let me separate these out. Then if 2a plus 1 is 17, 2a will be equal to, subtracting 1 from both sides, will be equal to 16. And then if 2a is 16, a will be equal to, dividing by 2, simply 8. 16 divided by 2 is 8. So here we get a to be 8. In this case, what's the value of a plus b? A plus b will be equal to, a is 8 and b is 0. So it's simply 8. Let's see what happens in the other case. So if the two numbers, these integers, are -1 and -17. So if they are -1 and -17, what will happen? In that case, 1 plus 2b, let's say it's -1, and 2a plus 1 should be then -17. Again, can be the other way around, 2a plus 1 being -1 and 1 plus 2b being -17. But again, since what we need is the sum of a plus b, it doesn't matter what's the value of a and what's the value of b. It's the sum that matters. So if this is the case, then again, let me separate it. From here, we get b to b, subtracting 1 from both sides. 2b will be -2 and b will be therefore -1, dividing by 2. Here we get 2a will be equal to -17, negative another one, which will be -18. So if 2a is -18, a will be equal to -9. So from here we get a to be -9. Now in that case, what's the value of a plus b? A plus b will be -9, negative another 1, because b is -1. So altogether it's -10. So in this case, we get a plus b to be 8. And in the other case, we get a plus b to be -10. Let me separate these out as well. So according to what they've given, the value of a plus b is 8, or it can be -10. Again, if I briefly explain what we did, we were given that a plus 2 times ab plus b is equal to 8, and also a and b are integers. So what I did was I multiplied both sides by 2 and ended up getting this, and then took the common 2 times a term out of the first two terms and ended up getting this. And we have a factor 1 plus 2b here in this term, And the same factor I created using the other term too by adding 1 to both sides. Then because that 1 plus 2b term is common, that factor is common for both these terms, I took that out and wrote that left-hand side as a product like this in the factored form. Now we have a product of integers is equal to 17 because it's given a and b are integers. These are integers as well. So if a product of integers is equal to 17, then what are the possibilities for those two integers? Can be 1 and 17 or -1 and -17. Consider the cases separately and figure out in each case what's the value of a plus b is. Can be either 8 or -10. Like that, we can solve this interesting Math Olympiad problem. Again, we will meet with another interesting Math Olympiad problem soon. Thank you.